In this video, we are going to explore the cell capacity testing machine and understand its importance in lithium-ion battery testing, validation, and battery pack development. As we know, batteries have become one of the most critical technologies in today's world. From smartphones and laptops to electric vehicles and large-scale energy storage systems, lithium-ion batteries are powering a wide range of applications. However, the performance, reliability, and safety of any battery pack depend directly on the quality of the individual cells used inside it. Before battery cells can be assembled into a battery pack, it is essential to evaluate their actual capacity, electrical performance, and overall health condition. Even cells manufactured in the same production batch may exhibit slight differences in capacity, internal resistance, and charging behavior. If unmatched or defective cells are used in a battery pack, they can negatively affect performance, reduce battery life, and create safety concerns. This is why cell testing is one of the most important processes in battery manufacturing and battery research. To perform this evaluation accurately, we use a cell capacity testing machine. A cell capacity testing machine is a specialized battery testing system designed to perform controlled charging and discharging operations on battery cells. It helps determine the actual capacity of a battery cell, analyze its performance characteristics, evaluate its cycle life, and identify whether the cell is suitable for use in battery pack applications. The machine demonstrated in this video is an 8-channel isolation cell capacity testing machine. As the name suggests, this system consists of 8 independent testing channels. Each channel can operate individually, allowing multiple battery cells to be tested simultaneously. Since the channels are electrically isolated, each cell can be monitored accurately without interference from the other channels. This significantly improves testing efficiency and enables researchers and engineers to perform multiple tests at the same time. Now, let's understand the major components of this testing system. The first component is the control unit, which serves as the heart of the machine. The control unit is responsible for controlling the charging and discharging operations, monitoring voltage and current values, executing program test sequences, and collecting data from all testing channels. The system supports up to 5 volts and 20 amps per channel, making it suitable for testing a wide range of lithium-ion battery cells used in electric vehicle and energy storage applications. The second component is the cell holder assembly. The cell holders are designed to securely accommodate different cylindrical battery cell sizes. Adjustable brackets allow cells of various dimensions to be tested safely while maintaining proper electrical contact throughout the testing process. The third component is the software interface. The software acts as the communication bridge between the user and the testing machine. Through the software, operators can configure test parameters, create testing programs, monitor live data, store test results, and generate detailed reports for future analysis. One of the most important features of this machine is its measurement accuracy. The machine utilizes the 4-wire Kelvin measurement technique, which is widely recognized as one of the most accurate methods for voltage and resistance measurement. In conventional measurement systems, cable resistance and contact resistance can introduce measurement errors. The Kelvin method eliminates these errors by separating the current path from the voltage sensing path. As a result, the machine can achieve highly accurate voltage and current measurements with an accuracy of approximately plus or minus 0.1% full scale. This level of precision is extremely important when evaluating battery performance and comparing cells for battery pack assembly. Now, let's briefly understand how a typical battery test is performed. The testing process consists of programmable charging and discharging operations. Initially, the battery cell is charged according to predefined current and voltage limits. During charging, The machine continuously monitors the cell voltage, charging current, and charging capacity. Once the charging process is completed, the cell may be allowed to rest for a specified period. This rest period helps stabilize the internal electrochemical reactions occurring within the battery. After the resting stage, the machine begins the discharge process. During discharge, the machine draws a controlled current from the battery cell until the lower cutoff voltage is reached. Throughout the entire testing process, important parameters such as voltage, current, capacity, energy, and time are continuously recorded and stored by the system. These measurements help determine the actual performance characteristics of the battery cell. The information generated from these tests is useful for a variety of industrial and research applications. One common application is cell grading. Since battery cells often have slight variations in capacity and performance, capacity testing helps identify cells with similar characteristics. These matched cells can then be grouped together for battery pack manufacturing, resulting in improved performance and longer battery life. Another important application is life cycle testing. By repeatedly charging and discharging a battery cell over hundreds or thousands of cycles, engineers can study battery degradation and evaluate the long-term health of the cell. The machine can also be used to evaluate internal resistance, which is an important parameter affecting power delivery capability and heat generation within the battery. In addition, capacity testing plays a major role in quality control. Before battery cells are approved for commercial use or integrated into battery packs, they must meet specific performance and safety requirements. Capacity testing helps verify compliance with these standards. All of these testing operations are managed through the software interface. The software provides real-time monitoring of all 8 channels simultaneously. Operators can observe important parameters such as voltage, current, capacity, energy values, cycle count, and testing status throughout the test. The software also allows users to create customized testing programs according to the specifications provided in the cell manufacturer's datasheet. Parameters such as charging current, discharge current, voltage limits, rest periods, cutoff conditions, and cycle count can all be configured according to the testing requirements. Another valuable feature of the software is data management. All testing data can be automatically recorded and exported for further analysis, documentation, quality reports, and research studies. The software can also generate charge-discharge curves and capacity graphs that provide valuable insights into battery behavior and performance. While discussing battery testing, safety is always a top priority. Lithium-ion batteries store significant amounts of energy and must always be handled carefully. Before starting any test, operators should verify proper cell polarity and ensure that cells are securely placed in the holders. Testing should be performed in a controlled environment with adequate ventilation and temperature management. If a battery cell exhibits abnormal behavior such as excessive heating, swelling, leakage, unusual odor, or unstable voltage behavior, the testing process should be stopped immediately and the cell should be isolated for further inspection. Following proper testing procedures and safety practices helps ensure accurate results while maintaining a safe working environment. In the next section of this video, we will move from theory to practice. We will see the complete operation of the 8-channel isolation cell capacity testing machine, including machine startup, cell installation, software connection, test program creation, charge-discharge cycling, live monitoring, data export, and final cell evaluation.